So today we have interesting problem about the modular division. Given the number k in the range of 10 to the power of 5, we want to find the length of the smallest number consisting of only ones that is divisible by k. So this is a problem, and I'll show you how you can think about it step by step to come to the solution. So we first let's observe what our constraints. So the k is 10 to the power of 5. It's pretty big, and this is one constraint. The second constraint is a number consisting only of ones. That makes our problem is much smaller than it can possibly be. So, and the third constraint is this operation. This is a modular operation, and it has some properties, like if you do A modulo B, and for example A can be like C plus D, for example, it can be transformed into C plus D modulo B, or even like this, C modulo B plus D modulo B. The same property is for the multiplication. For example, A is Y times Z, and that can be transformed for like this times Z. So this operation is pretty I would say simple. So let's return to our problem. We can look at it at two angles. The first angle is how can we find, how can we rewrite this model operation on some particular number. If the numbers consisting of ones is called n, and it is divisible with modulo k, that can be transformed into like x times k equal 1. So that means our n consisting of k times some number x. For example, we have number 111 and k is 3. That means if this model is 0 and it is 0, we can say that 37 times 3 is 111. But knowing that, is this simplify our problem? I don't think so, because we still have to find this number x, and it can be pretty big because the number 111 can be very large. It can be more than 10 to the 60 and so on. So we have to look from another angle, and another angle is these properties of model operations. If we can't find this number from the transformation, let's go from this number. So imagine we have this number. We have it. Let's just check every possible number. It can be pretty lengthy, so let's make it like 10 to the power of 5 length maximum. And now we want to check every prefix if it is divisible by k. And there comes our model operations. So first we check this 1 times k. Then we check 11 times k. Then 111 times k. And so on. Eventually we have a very, very big number, and it doesn't fit into long value. The long is 2 to the power of 64. So it has 64 bits, and it's not that lengthy. So our length is 10 to the power of 5, and this is also only 64 bits. This is base 10 and this is base 2, but they're still very, very different. So there comes our model operation. What does it mean to build the big number from small number? Each time we go from 1 to 10 to 11, I'm sorry, and then from 11 to 111. And to make this jump, we do the previous number times 10 plus 1, and this is also times 10 plus 1, and so on. So we have a running operation like previous number times 10 plus 1. And then we check modulo k. And the rule of the model operation tells us that we can skip calculating the actual exact value. We can just do like this: plus 1 modulo k. So x equals. But how can we check if it is divisible by k? Because we already do modulo operation. And what does it mean to say that number is divisible by k? Actually, this is pretty simple. If x equals 0, that does say to us that it is divisible by k. So this is entire algorithm, and it works. Let's look at the code. It is like that. We just find this number. You have to prove that this is like the most this can be used like the maximum length, and I hope we have a good proof of that. But let's look at the k. The k max is 10 to the power of 5. Can we prove it like from this range? How is the max length? The length is logarithm of number x, and I take that the maximum length is 10 to the power of 5. And that means that the number x is 10 to the 10 to the power of 5. It's a pretty big number, but does it actually correct. So the k max is 10 to the power of 5 too. And we have like this equation like this. It's 10 to the power of 5. It is the x is 10 to the power of 10 to the power 5. And this is some multiplier. So I have the good proof for that. Let's look at the editorial. Maybe we find one. So they just use this remainder and sin remainder. So they actually have a different solution. Like there are loop. So you don't have to prove this 10 to the power of 5. Actually, there is only k remainders. Because every time you do modulo k, you have something from 0 up to k. And when you loop, it means that you didn't find any no new remainders. However, the 10 to the power of 5 is the of one solution of n solution, and it's generally acceptable. However, you see that my solution is 12 milliseconds and the optimal solution is 2 milliseconds. So it can be improved by this proof. Okay, that's even more tricky. So this is a mathematical algorithm. Okay, the set is actually less optimal. So if it's divisible by 2 or divisible by 5, interesting. I don't know how can you reason about that. Maybe this is because 10 is 2 times 5. Maybe not. So that's it. You can watch how I solved this in 12 minutes.